the last lesson that we have in Trig 1 is lesson number 10. It's on page 575 of your student workbook. And this is going to be the second problem solving lesson. What we're going to be doing in this one is you're going to be doing the opposite of what we did in lesson 9. So lesson 9, we were given the equation and we made the graph. This lesson, we're going to be given a graph, and from that, we're going to be making the equation. Okay, so then you've covered everything. Okay, so let's look at this first example in the review. What it says is the sinusoidal wave shows a maximum value of 50. So let's put that in. It says that the max of this graph is at 50. And it says the minimum value of this graph is at 10. So that would be 10. You could check the scale, but what the scale on the y-axis would be, how many boxes are you counting up to get to 15? You would say 1, 2, 3 boxes. 15 divided by 3 is 5. Each hatch mark is worth 5, right? 5, 10, 15, 20, 25, 30. So we've got our maximum and our minimum there. Let's actually quickly figure out what the scale down here would be, because it's going to help us with our period. How many boxes are you counting to get to 16? So what would one box be worth? Kieran, do you know what that would be? 4. Yes. You're counting up 4 boxes. So on the x-axis, one box would be 16 divided by 4, which is 4 seconds. Each box is going to be 4 seconds. So 4, 8, 12, 16, 20, 24, 28, 32. So it makes sense. Okay, write the equation of the sinusoidal wave in this form here. So they're just saying, like, we got to find everything. The D value, the A value, the phase shift. They're only telling us that this is a sine graph. Okay, when I do these questions, where I always want to start is that midline. That's where I always start. I want to put the midline in first. So the midline is your D parameter. And remember that the formula for the D parameter, it's max plus min divided by 2. So the max of this graph is 50. The min of this graph is 10, because they gave me the maximum. That's all they gave me. And then we're going to divide that number by 2. 50 plus 10 is 60. The midline of this graph is at 30. So the D value is 30. So now take your ruler and at 30, get your midline in there. So that's my midline there. And then from there, you should be able to see the amplitude. So the amplitude is the height from 30 to 50. So the amplitude of this graph is going to be 20 units, right? And if you needed to, you could use the formula for amplitude, max minus min divided by 2. But just by counting, the second part that I would do would be the amplitude. And the amplitude from 30, so that's going to be 5, 10, 15, 20. So it's going to be 20 units. So now I know my equation. This guy is 20, and this D value is 30, right? I found 2 out of my 4 parameters. Okay, the period. I'm going to show you 2 ways, again, that we could get period for the sine graph. So it could be from here to here. That's one way to get period. And that would be 32 seconds. So for number 3 for period, it is 32 seconds. Oh, wait a second, maybe they want that to be minutes, it doesn't say. Yeah, they don't tell me what the time is. what t is here. It could be in minutes, it could be in seconds, I'm not really sure. So I'm actually just going to erase this seconds because it doesn't, I don't know for sure. So 32. Let's check peak to peak, and if we get that same 32. So from this peak here, it's kind of hard to see. I might need, so from that peak, do you agree that that would be 24? So that would be 24. If I go to the next peak, so I just have to move that over so I can't see. That would be, what would that be? 48, 52, 56. So the period, if I was going from peak to peak, would be, well, what's the distance you would go from there to there? 56 minus 24. You could check that on your calculator, you'll get 32. So whichever way we're doing this, we're getting 32 as our period. Now, once we have our period, go ahead and calculate your b value. So the formula for b is 2 pi divided by period. Which is going to be 2 pi divided by 32. 2 goes into 2 once, and 2 goes into 32 16 times. So my b value is pi over 16. So this right here is going to be pi over 16. Now we need to do the phase shift, right? So we need to see what the phase shift is, the c value. And remember that on a sine graph, so from sine we always measure from the midline. So like this here, if that I moved over here, that's the original sine graph, right? It starts at the midline and it rises. And then how many units did I move it to get to there? 16 units. So my phase shift, because it's going from here, it's starting and it's going to there, that is 16. So the fourth and last thing I always do is I figure out my c value. It's 16 seconds, minutes, whatever they wanted that to be, and it's going to the right. So c is going to be positive, but now I could fill all of this in. So my final formula is going to be the height according to time is 20 sine, b is pi over 16, x minus 16 because we want it to go to the right, and then plus my d value, which is plus 30. So that's what we're going to be doing. We're going to be doing 2 more examples where we're going to be getting an equation from some sort of a real life scenario. Okay, here is the first real life scenario. A nail is caught in the tread of a tire, and the nail, they just, for whatever reason, they're going to start the graph, the nail is right there. So when you guys get like a nail or a rock in your tire, as you drive, it's going to be like, you're going to hear like a tick, tick, tick. And every tick is basically the nail when it gets to the ground, right? So every time it rotates and the nail's on the ground, you're going to hear a tick. So what we're going to do is we're going to figure out some things just based on this very little information that they gave us. This is going to be the height of the nail. So this is going to be like, it says height in centimeters. So that's going to be the height of the nail. And they just tell us this is in time in seconds. What it says is a tire has a diameter of 50 centimeters. So the diameter of this tire is 50. The diameter is actually useless in this question, but we'll write it down. The diameter is 50 centimeters. What can I calculate from diameter? Not period, not just yet. What can I do with diameter, Viola? No, I don't even need that. The radius. if you have the diameter, you could divide that number by 2 and you have the radius. Here's why knowing the radius is helpful. So watch this. If I tell you guys that this is the center of the tire and this is 25, what parameter did I just give you? The amplitude. So what I want you to star somewhere on here is whenever you have a circle and the radius, whatever the radius of your circle is, that is your amplitude. So the radius is 25 centimeters. That means that the amplitude is 25 centimeters. And that should make sense, right? If this whole thing, so let's put in, you guys, what's the maximum going to be? 50, right? The diameter or the tire has a diameter of 50. That means that my max is 50. It's going to go from 50 to 0. Halfway, like this is going to be our midline, right? So that's going to be our midline. We're easily going to be able to see what our midline is, but I could also see my amplitude. So whatever the radius is, right away, you tell me that that is your A value on these graphs. And we're going to do a Ferris wheel next. Whatever we can figure out the radius of the Ferris wheel is, that's going to be the amplitude of our graph. Okay, so the tire has a diameter of 15 centimeters. And it rotates 10 revolutions per minute. So we're going to write this down. We're going to figure out what this means. This is going to help with our period. So let's just write this down for a second. 10 revolutions in 1 minute. Okay, to figure out what the period of this graph would be, I got to convert it to seconds, right? Because they tell me that this is in seconds. So that would be 10 revolutions. 1 minute is the same as 60 seconds. And then 10 goes into 10 once. It's going to be one revolution, you guys, in how many seconds? 6 seconds. 1 revolution is equal to 6 seconds. 1 revolution is the period of this graph. So 6 seconds, that is the period. Whatever 1 revolution is. When your Ferris wheel spins once around, that's going to be a period, what we'll see. Okay, so we'll deal with that 6 seconds later, but that's going to be my period. Then it gives me this piece of information. It says after 4.5 seconds, the nail touches the ground. Do you know where you would write 4.5 on here? So the nail starts here. After 4.5 seconds, you hear the first thud in your car. What do you think, Kelly? That's right. This right here would be 4.5 seconds. Because it says after 4.5 seconds, the nail touches the ground. If that's where the nail starts, this would be 4.5 seconds. What would this be?
9.
That would be 9 seconds. Okay, and then our period, if we were to go from peak to peak, would be 6 seconds. So if you were to divide 4.5 by 2, right, figure out what that is, figure out what this is, that would be 6 seconds. But you get it from this 1 revolution is in 6 seconds. Okay, so from here, let's see what we have. So we've got quite a few things on our graph. Use the information to write a scale for each axis. Okay, so write down what you think the scale would be. Like, what would your scale based on this picture be? So if I was doing the scale for the x-axis, I'm going from 0 seconds. According to this picture, I'd have to go past 9. What do you guys think this is? If that's 9, so if from here to here is 4.5 seconds, what would this be? That would be half of 4.5. What is it? 11.25. So let's not go to 11.25, let's go to 12, right? So from 0 to 12. So our scale could be from 0 to 12, and we'll go up by 1 second. Okay, the y, and we're not even going to graph this, like we're not going to graph this, but the y would be, I don't want to go from 0 to 50, I want to go slightly past 50, so I'm going to say 0 to 60, right? That would be enough, or 0 to 70, you'd be fine with that. As long as you could see your window. We could go up by 1s, you could go up by 2s, whatever you want. Okay, determine the equation for the height of the nail as a function of time in this form here. So this tells me a few key things. They tell me it's a sine graph, okay? They tell me there's an A parameter, a D parameter, and a horizontal stretch. So there's no phase shift. That's what this is telling me, okay? So going based on this, I know what my amplitude is, right? My amplitude is the radius. My amplitude is 25. So I'm going to write my A is equal to 25. I guess it would be centimeters. That's my amplitude. What is your D value? Marley, what would the midline of this graph be? 25, yeah. Let's just double check doing the math though. So for the D value, remember that D value is max plus min. Max plus min divided by 2. A value is max minus min divided by 2. So the D value, the max was 50, the min was 0 divided by 2. 50 divided by 2 is 25. So my D value, the midline of this graph, is also at 25 centimeters. Okay, so I'm going to put that midline in. So that there is my midline. The height of the graph is 25. From 25 plus 25 takes me to 50. So far, it's making sense. From this peak to this peak should be 6 seconds. That's my D value, or sorry, that's my B value. So now let's get our B value. So our B value is going to be 2 pi divided by the period. The B value is going to be 2 pi, the period is 6 seconds. That reduces to pi over 3. So from there, we've got the full equation of this graph. The height of the nail, according to time, is equal to, so we got to fill this in, 25 sine. The B value is pi over 3 times t. T is your x, though, on your calculator, and then plus your D value. Your D value is 25. That is your equation there. Last question, how far to the nearest tenth of a centimeter is the nail above the ground after 6.5 seconds? So I don't want to really enter this into my, graph it. So what I'm going to do, they want to know at 6.5 seconds, so it's going to be somewhere around here, what is the height of the nail? If this is my formula, I'm going to take out t and I'm going to put in 6. So the height of the nail at 6 seconds is 25 sine. The bracket's going to open on your calculator, so it's going to be pi over 3 times 6 plus 25. The height of the nail at 6 seconds is equal to, so let's see how we calculate this. You guys, pi over 3 times 6, what is that the same thing as? So that's 6 pi divided by 3, that's 2 pi, right? Pi over 3 times 6 would be 2 pi. So if I was to go here, or I'll show you how you can enter it the other way. So 25, yes.
6.516.
Thank you. That would change things. This, yes, 6.5 seconds, that should be 6.5, 6.5. Oh yeah, that's gonna change this. 6.5. Okay, let's enter it the other way. Okay, 25 sine pi over 3 pi divided by 3. So really that should be in a bracket, right? Like pi over 3 should be in its own bracket, and then that guy times 6. So how I'm actually going to enter that is I'm going to enter this in its own bracket. So pi over 3, that number times 6.5. So there's my pi over 3 in a bracket times 6.5. And I've closed that first bracket that was initially opened, plus 25. At 6.5 seconds, the height of the nail is 37.5 centimeters. So the height of the nail at 6.5 seconds is 37.5 centimeters. And you'd be done that question. Let's do the Ferris wheel question. And your exam question is the Ferris wheel question. So what I do for this one, I don't like how they set it up in the book. They give you this in your book, and I would never give this little chart on a test. Okay, I'll show you what you would get on a test. I will just give you a grid, and I'm going to show you how to draw the Ferris wheel, like how we make the wave, and then how you get your equation from the wave. Okay, and we'll cross out what's not necessary on here. Okay, the first Ferris wheel, if you want some history, ever built was created by a bridge builder. So a bridge builder actually built the first Ferris wheel. Here's his name, that's the date, not relevant. We want this first piece of information. The diameter of the wheel is 76 meters. So let's write off to the side. The diameter of this Ferris wheel is 76 meters. Logan, what am I going to do with the diameter? You're going to divide it by 2 to get the radius. And Logan, do you have what that is? 38 centimeters. And then Logan, as soon as you have the radius, what parameter did you just calculate? The amplitude. So the amplitude of this graph is going to be 38 meters. So basically what it's saying is it is saying from the center of this graph, like that's 38, this is 38, right? 38 and 38 would be 76, but I've just got the amplitude. Okay, so the next thing that we're going to do is, let's see what it says. The maximum height of the Ferris wheel is 80 meters. So we need that to go in. So I think I might have put that in for you, but it says the maximum height is 80 meters. So the people get on the Ferris wheel here, and when they get to the top of the Ferris wheel, they're at 80 meters. Then they're gonna go back down here, and this is where they get on and off. You climb up a little ladder or a step stool to get onto a Ferris wheel, okay? So it says the maximum height of the Ferris wheel is 80 meters. And does it say the minimum height anywhere?
It's in the truck.
Oh yeah, okay. So what I would say on the test or something like that is there's always a platform. Like your chair isn't on the ground, right? Your chair in a Ferris wheel is never on the ground. They will always tell you what the platform is. And this is a 4-meter platform. So you climb up like some steps, you sit in your little basket or whatever you sit in, and this is 4 meters off the ground. That's your minimum, okay? So they told me up here that at 0 minutes, when it starts, they're 4 meters above the ground. But how I would say this in the question in your book or on a test is I would say, you know, the max height of the Ferris wheel is 80. The platform is at 4 meters. Yes?
If we didn't tell you the height of the platform, could you just do like the maximum minus your diameter?
Yeah, I think the
Yes,
maximum is there.
that's the other way. Absolutely. So they told you this here, which I would never give, right? You're not going to be given this, but absolutely, yeah. If you know what the maximum is, so 80 that would be a really good question, right? 80 minus 76, that means that the platform is at 4 meters. Yeah, that's perfect to get that. Okay, this whole thing, this is irrelevant. How many carts are on a Ferris wheel does not matter. How many people can go into each cart, none of that matters, right? You just get on your Ferris wheel. Your little cart starts 4 meters above the ground. When you're at your highest point, you're 80 meters. So this is a huge Ferris wheel, right? This Ferris wheel. Okay, this is important. The wheel rotates every 9 minutes. So what that means is this. They were super slow back in the day, back in the 1800s. Do you know what 9 minutes is?
3 seconds.
That's the period. From when you get on, it's going to take 9 minutes for you to have your ride. One ride, one revolution around is 9 minutes. So the wheel rotates every 9 minutes. That is the period. Okay? So the period is equal to 9. Now, for these Ferris wheel questions, what you want to do and what you want to star is you want to divide your period by 4. And I'm going to show you why. So write down divide period by 4. So if we take 9 and we divide it by 4, what does that give us? 2.25 minutes. Okay, so I'm going to show you what we're going to use this for. 2.25 minutes. This is going to help with your scale. Scale. Okay, so what that means is this. I don't want each hatch mark to be 2.25 minutes, but just watch what we're going to do and then it will make sense once we illustrate this. I want you to count up 5 boxes and we're going to put 2.25. So 1, 2, 3, 4, 5. 2.25. Then if you did another 5 boxes, 1, 2, 3, 4, 5, that would be 2.25 plus 2.25 is going to be 4.5. That's 4.5 minutes. And then go 5 more boxes, 3, 4, 5, and that's going to be 4.5 plus 2.25 is going to be 6.75 minutes. And then 5 more boxes, 1, 2, 3, 4, 5, that's going to be 9 minutes. So they only want one complete cycle. So they want one complete cycle. So they just want to go from, they want to show 0 to 9 minutes is what they want you to illustrate. So like I said, you take whatever the period is and you divide it by 4. And then you want to use as much as your grid paper as possible, right? So I could have counted up maybe 6 boxes and put that at 2.25, but this is going to be one revolution. It's going to be 9 minutes. Okay, let's get our midline in there. So let's get our midline in here because I always do everything from the midline. So the midline, remember the midline is max plus min divided by 2. So the midline of this graph, the max of this graph, they said was at 80 meters. The min of your Ferris wheel is at 4 meters, right? That's where the platform is, divided by 2. So that's 84 divided by 2. 84 divided by 2 is 42 meters. So 42 meters. So it's not going to be perfectly to scale, but 42 meters, so from the center. So that's approximately going to be the midline. And I think I was going up by 5s, like 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80. So 42, maybe I got to raise that just a little bit. But yeah, that's about the midline. Okay, here's why we divide to figure out our scale by 4. So you guys, the people get on the Ferris wheel right here, right? Everybody agrees with that? How, at 0 seconds, how high are they at this point here? 4. So that's going to be right here. Then they travel a quarter of the way around the wheel, and they're right here, which is on the midline. Now, how many seconds or how many minutes did it take to them to get here? If it takes 9 minutes to go all the way around, what is a quarter of 9? Or what's 9 divided by 4? 2.25. So at 2.25, they are at the midline. This is why you really want that scale. Then, if they go another 2.25 minutes, they're at the maximum now. So now, at 4.5 minutes, they're at the peak at 80 meters. So they're going to be right there. Then they're going to go another 2.25 minutes, and they're going to be back in the midline, because this is the midline. Halfway is the midline. So at 6.75, they're going to be back at the midline. Then another 2.25 minutes, they're back where they started. They're back at 4 meters above the ground, to be right there. So our picture, when you turn a Ferris wheel into a sinusoidal curve, that's what it looks like. You start 4 meters at the platform. Here, you're a quarter of the way up your Ferris wheel. Here, your ride is half done, and you're at the peak of your ride. You're at the maximum. Here, you're 3/4 of the way along your Ferris wheel. And then here, you're back at 0. Not at 0, but you're back at 4 meters above the ground. You get off your ride. Your ride, 9 minutes long, you're done. Okay, so now that we have all of this, let's see if we could write our equation. So I know that D is 42, right? I know that that guy is 42. I know my A value. My A value, we figured out, was the radius. It is 38 meters. So my amplitude is 38 meters. I know that the period is 9 minutes. And what period is used for is the B value. So the B value is 2 pi divided by period. It is 2 pi divided by 9. I can't simplify, that's my B value. And then now I just have to figure out the phase shift. So the last thing I always do, so again, first thing, second, third, fourth. C value, which is your phase shift. That is your phase shift. Because remember, the coast graph, this guy down here, if I move that over, so if you want to see, I could show you. So this guy, that before the phase shift would have been over here. And then it just got moved over. So what's your C value? 4.5. So your C value is 4.5. And now we have everything. The height of the Ferris wheel according to time in minutes, A cos of B. So 38 cos of 2 pi over 9. In brackets, I need my phase shift. So my phase shift is 4.5 to the right, so x minus 4.5. And then I need to add my midline, which we said was 42. Okay. So this is almost going to be identical to what you're doing. They love asking these Ferris wheel questions on diplomas. So you could expect this. The only thing, you're going to do always the same thing. So when you practice this Ferris wheel question, whatever one revolution is, you divide that by 4, right? So whatever, like I said, one revolution is, divide that by 4, and that will help you figure out a quarter of the way around the graph, halfway around your Ferris wheel, 3/4 of the way, and then back to the start. The only thing you have to be careful of is on your test, this one asks for 1 complete cycle. I might ask for on your test 2 cycles, right? So then within your grid paper, you would need to get 2 cycles in there. So how you would do that is students are like, okay, well, how would you do that if they wanted 2 cycles? Basically, you'd have to go to 18 seconds. Does that make sense? So I couldn't count 5 boxes up to 2.5. I might go 3 boxes and then say that's 2.5. 3 more is 4.5. 3 more is 6.75. Then 9. Then you just keep adding 2.25. Okay? C, how high to the nearest meter is the cart 5 minutes after the wheel starts rotating? So they want to know, here's 4.5 minutes, 5 minutes, what's going to be the height of the cart? So I want you to punch in on your calculators. The height of the cart at 5 minutes is equal to 38 cos 2 pi over 9. This has to be in a bracket because that's a fraction. Oh, and then it's going to open up that other bracket for us. X minus 4.5, we're going to close 2 brackets, plus 42. So let's see if we could get that. So, oh, and X would be 5. I should change that to 5. That would be 5. Okay, so let's see what we would get if we all type it in and get the same thing. So 38. Actually, I should clear this. 38, it's a cos graph. They want my b value first. So I'm going to put my b value in its own bracket because it's a fraction. And the b value is 2 pi divided by 9. So 2 pi divided by 9. And then I'm going to put the 5 minus 4.5. 5 minus 4.5. I'm going to close that bracket and that first bracket. And then plus 42. So 5 minutes after the Ferris wheel starts, you are 78 meters off the ground at 5 minutes. So the height of the Ferris wheel at 5 minutes is 78 meters off the ground. Okay, after how many seconds after the Ferris wheel starts rotating does the cart first reach 10 meters from the ground? So 10 meters from the ground is here, right? That's 10 meters from the ground. So they want to know when it first starts rotating, after how many minutes are you 10 meters off the ground? This is a Y2 question. It's an intersect question. So Y2 is going to be equal to 10. Oh, we would have to punch this whole thing in our calculator, which we haven't done. Oh, we might as well do that. Let's punch this in. So Y2 is going to be 10. This guy is going to be 38. Cosine, the b value, 2 pi divided by 9. And then x minus 4.5. Close 2 brackets, plus 42. I'm going to have to change my window. This is going to help me I'm going to go up to 100. Are you okay with that? I'm going to go to a maximum of 100. And I'm gonna change I'm gonna go to 10 minutes on here. So for my window, I'm gonna go from 0 to 10 minutes. I'm gonna go up by 1 minute. Even though it's not going up by 1 minute on here, that's fine. My Y, I'm gonna go from 0 to 100 meters off the ground. And I'll just keep that scale at 1. There's your Ferris wheel. This is the Ferris wheel when it first reaches 10 meters off the ground. You go up to your top, you come down. This is the second time 10 meters off the ground. The question is asking after the wheel starts rotating. So this is where it starts rotating and what's that intercept? So second function calculate, number 5. And we're gonna hit enter 3 times. Ooh, this is in minutes. They want it in seconds. Do you know what you're gonna multiply this number by to get the answer in seconds? 60. Yeah, because we know that our axis was in minutes. So that's how many, in 0.81 minutes, it's 10 meters off the ground. Let's figure out how many seconds that is. So get your X value, that's in minutes, times that by 60 to get to seconds. So that would be 49 seconds. So after 49 seconds, the Ferris wheel is 10 meters from the ground. You will get to practice this question once in your homework, and then I'll give you a review tomorrow. You'll get a practice once in your review. So for your homework, I want you to do only 3 questions from here. I want you to do questions 1, which is a Ferris wheel. 2 is a Ferris wheel. 4 is a depth of the water question.